today let us study about the degree of a polynomial. Let us start with something basic. Here you have a polynomial. What is its degree? Its degree is the exponent of the variable that you see here. So what you see here is a polynomial of degree 9 in the variable x with just one term. What if it has more variables? For example, what if you have something like this? Then what happens? Then add all the exponent, whatever is the exponent of the variable, add all of them. 9 plus 7 plus 2 will give you 18. So what you have is a polynomial of degree 18 in the variables x, y and z, but still only one term. And what do we call a polynomial with one term? We call it a monomial. It has just one term. Now shall we move on to more terms? Now from one term let us move on to more than one term. Here we have three terms. What are terms? Terms are expressions which are separated by a plus sign or a minus sign. So you have how many terms here? 1, 2, 3. You have three terms. Such a polynomial is known as a trinomial. One term, monomial. Two terms, binomial. Three terms, it is known as a trinomial. So what you have is three terms. What all variables? You see an x, you see a y, you see a z. So in three variables. Now we come to today's topic, which is the degree of this polynomial. For that, find the degree of each term separately. So the degree of the first term we have already found. 9 plus 7 plus 2, 18. This is 2 plus 3, 5. And here it is just 100. Do not worry about this constant here, this 7 or this 8. Do not worry about this constant. All you have to see is that it is not 0. Now the degree of this polynomial is the greatest among these three numbers. Look at these three numbers. What is the greatest number? Which is 100. So 100 is the degree of this whole polynomial. What you have is a polynomial of degree 100 with three terms in the variables x, y and z. Now let us see some special cases. Some places where you cannot see the degree but it is there. Let us see those cases. Now let us quickly remind ourselves of some basic laws of exponents. Any number raised to 0 is 1. Any number raised to 1 is that number itself. The same follows for the variables also. Any variable raised to 0 is 1 and any variable raised to 1 is that variable itself. Now as far as the exponents of the polynomials or as long as the degrees go, can the degrees be negative? No. Can they be a rational number? No. Why is that? The degree of a polynomial cannot be negative. It cannot be a rational number. Why? Because it has to be a non-negative integer. That means it can only have degrees which look like 0, 1, 2, 3, etc. You can only have x raised to 0, x raised to 1, etc. Now let us see some special polynomials and see what their degree is. We start with a constant polynomial. When I say constant, I mean a non-zero number. You cannot give me 0. Give me any other constant. What about 5? Or what about pi? Pi is just 22 by 7, right? It is a rational number. Or what about 4 by 3? So these are all constants. Are they polynomials? Yes. In what degree and what can be their degree? You see a 5, but what is it actually? It is 5x raised to 0 because x raised to 0 is 1. So it is actually 5 into 1. We just don't bother writing it. It is there. You just don't see it. So 5 is also a polynomial. Its degree is 0. Same with pi. Pi can be written as x raised to 0. You just don't see it. It is there. So all the constants, whatever constants you have, whatever non-zero number you have, it is a polynomial. It is known as a constant polynomial and its degree is 0. Now we move on to the zero polynomial. What is the zero polynomial? It is just 0. So clearly its degree is not defined. Now if you want a mathematical explanation to it, think of the sky. Why do you say that the sky is blue? When I see, it is blue. When you see, it is blue. When somebody in the Amazon forest or wherever people see, when they look up, they will see that the sky is blue. But then what if I look up and I see green, you see blue, somebody else sees black? Then what do we say? Then we say that the sky's color is not defined, because each one of us has a different story. So that is what happens with the zero polynomial also. Now you give me the zero polynomial and I say 99 is my favorite number. So I am going to write this 0 as 0 into x raised to 99. Is it correct? Yes, it is. This is still 0. I haven't changed anything. I have just kept the 0 as it is and I have written it like this. So I am saying its degree is 99. Then somebody else comes and they say my favorite number, my favorite alphabet is Y and my favorite number is 24,800. So now this person will say that zero polynomial, its degree is 24,800. That person is also correct. Why? Because 0 multiplied with any number will give you 0. That person is also going to tell it is some other number. But is that possible? Degree can only be one number. Each one of us cannot come and give a different number, right? So degree can just be one number. So we say that it is not defined. Now we go on to, from the 0 degrees, we go on to of degree 1, 2, 3, etc. So I will take randomly, I will take degree n. This n can be anything. It can be 5, it can be 6, it can be anything. Then a polynomial, this is how you represent it. This means a polynomial in the variable x. It will look like this. Now any polynomial of degree n will look like this. What does it mean? It means just because it is of degree n does not mean it does not have any other variables of any other degree. It has only that should be less than n. It cannot be more than n. It will be, for example, if you take something of the degree 4, then it will have an x raised to 4, it may have an x raised to 3, x square, x raised to 1, x raised to 0, which means what? X raised to 1 is just x and this is a constant. There will be a constant there. So if it is of degree 4, it will have x raised to 4, x raised to 3, x raised to 2 and it will have all of this. But what it cannot have is x raised to 5 or 6. And what it cannot have is a 0 coefficient there. Then we have a problem there. Why? Because if it has a 0 coefficient, this whole thing will become 0. Then it will become a polynomial of degree 3, not of degree 4. So always if it is of degree n, its coefficient cannot be 0. But anything else can be 0. If you have an x raised to 4 here, its coefficient cannot be 0. But then if you have a 0 here, that is fine. It just will not have this there. Plus this into say 27. We just need to be any numbers, an minus 1 and a1 and 0. All of this can be any number that you can think of. Any positive, any negative number that you can think of. These numbers can be any number that you can think of, but make sure that your an cannot be 0. So your polynomial of degree 1 will look like this. It will look like this. It will have a x raised to 1 and then it will go down and it will have an x raised to 0 term. It will have such two terms. B can or cannot be 0, that is fine, but a cannot be 0. And this is your polynomial of degree 2. This a cannot be 0. It has to be a non-zero number. It has to be 1 or 2 or 5 or square root of 2 or whatever it is. But then this b can be 0, then you will just not have an x term. Then this c can be any constant number that you can think of. So if it is of the degree 2, it will and it has to have an x square term. It may or may not have an x term. It may or may not have a constant in any form. In this class we studied about the degree of a polynomial. In the next class, inshallah, we will study about the zeros of a polynomial, and we will see how the degree and the zeros are connected. But that's for another class. Till we meet again, you take care. Assalamu alaikum.